I'm Anil Kumar, and here is solution of question number 9, page 140 for my student Ryan. This is from Nelson, Calculus and Vectors. The question here is, the forward motion of a space shuttle t seconds after touchdown is described by s of t equals to 189t minus t to the power of 7 over 3, where s is measured in meters. What is the velocity of the shuttle at touchdown? How much time is required for the shuttle to stop completely? How far does the shuttle travel from the touchdown to complete stop? And part D was to find the acceleration. Okay, now let us understand the question itself. When it says what is the velocity, you need to find the first derivative of displacement to get the velocity. At touchdown, at t equals to 0, since t is seconds after touchdown, so at t equals to 0, you need to find velocity. So that is the first part. Then how much time is required for the shuttle to stop completely? When the shuttle stops completely, its velocity will be 0. So the derivative which you get in part A, equate it to 0, find t, time, and substitute time in displacement equation given to you to find the displacement. How far does the shuttle travel from touchdown to complete stop is what you will get, right? So let us do them step by step. So first step is find the velocity. So v of t, which is derivative of displacement, in this case will be equals to 189 minus 7 over 3 t to the power of 7 over 3 minus 1. That means 7 minus 3 is 4 over 3, right? So that is velocity expression in general. What is the velocity of the shuttle at touchdown? That means at t equals to 0. So substitute 0 for t and find your answer. So when you substitute 0 for t, what you get is 189. The units are meters per second, right? So write down units, meters per second. So that is part A. Now part B is how much time is required for the shuttle to stop completely. To find this time, we have to equate the velocity expression to 0. So what at that time vt equals to 0, right? So that means 0 equals to 189 minus 7 over 3 t to the power of 4 over 3, right? These numbers 189, 7 over 3 are excellent numbers to work with in this particular example, since they can help you find the answer without calculator also, right? Let us see how. So we can say 7 over 3 t to the power of 4 over 3 is equals to 189. So t to the power of 4 over 3 is 189 times 3 over 7. Now when you divide 189 by 7, 7 times 2 is 14 and 49 is 7 times 7. So what you get is 27 times 3. This is what you get, right? So 27 times 3 is actually 3 to the power of 4. Do you get the point? So 27 times 3 is 3 to the power of 4. Got it? So that helps you to find t itself. Do you see that? So now from here, what do we get ts? So t is equals to, we could write 27 is 3 to the power of 3, right? So this is 3 to the power of 4. So we have 3 to the power of 4 and to the power of 3 over 4. Do you see that? And when you multiply, you get 3 cube, which is 27 seconds as your answer. So these are excellent numbers to work with. Therefore, I didn't use the calculator to show you the answer. So at time t equals to 27 seconds, it will stop completely. Now part C here is, so let me divide the page. So we'll do part C on the left side. How far does the shuttle travel from touchdown to complete stop? That means we need to find, so we are doing part C. So we need to find displacement at t equals to 27. That is what it is. So replace t with 27. So you get 189 times 27 minus 27 to the power of 7 over 3, right? So once you calculate that, you get your answer, correct? 27, as you know, is 3 to the power of 3. So you could actually use calculator at this stage and calculate, but I will show you how to use without using calculator. You could do it, since you know 27 is 3 to the power of 3. We also know 189 is 27 times 7. Just now we learned, right? 27 times 7. So I'll write this as 7 times 27 times 27, right? And here I'll write 3 to the power of 27 is 3 to the power of 3 to the power of 7 over 3, right? So this is 3 to the power of 3. This is also 3 to the power of 3. So we get 7 times 3 to the power of 6 minus here we get 3 to the power of 7. And now you can take 3 to the power of 6 common. So when you take that, you get 7 minus 3. So your answer is 4 times 3 to the power of 6, right? You can calculate using the calculator. Well, you could have done it straight away. There was no need to do all this. But I'm just showing you these calculations since they are very interesting, right? So, and I hope it helps you to visualize. 2916 is your answer. So 2916. So answer will be 2916 in meters, right? 2916 meters. Well, to find acceleration, what you can do is you can find derivative of this particular function. That is part D, which I didn't really type because I'm running out of space. Acceleration will be a derivative of velocity, so which will be minus 7 over 3 times 4 over 3 t to the power of 4 over 3 minus 1. So 4 minus 1 is 1, 1 over 3, right? So you can simplify this expression. We're just kind of multiplying these numbers, right? 7 times 4 is 28, so it is minus 28 over 9 t to the power of 1 over 3. So that is in meters per second square. So that is the expression for your acceleration. You can substitute time, whatever given to you, and calculate to find the acceleration for that particular time. I hope that helps. Thank you and all the best.